Let me introduce you Professor J Sedliacik. He's an expert in gluing, adhesion, and he will show you what does it mean, how to glue wood which was a little bit treated, thermally treated, and or some other different surface properties arranged on the wood. So, meantime, when he will talk, I will give you again a list for today. Please sign it up and return it back to me. Okay, Professor Sedliacik, the floor is yours.
Thank you very much. Ladies and gentlemen, dear students, allow me to introduce my presentation titled Gluing of Wood with different process surface, which is aimed on the material which you are working with all the time here in Lulen. This material could be called as thermo wood or pressed wood or thermally created wood, and this type of wood has very special conditions for gluing or painting. So, and there are arising a couple of problems, and I'm going to try to explain you how to solve these problems and how to glue this type of material. After thermal and pressure treatment, woods have outdoor applications attributed to their enhanced properties, such as reduced hygroscopicity, improved dimensional stability, and improved resistance to degradation by microorganisms. There are very positive properties for such wood, but excessive heat and pressure can cause problems during gluing or of paint application, because the surface properties are changed and the wettability of wood decreases after effects of high temperature and treatment. How to explain and how to solve these problems? I'm going to start with some knowledge from basics from the theory of gluing. We know that adhesives are liquid materials, or at least during the application on the surface are in liquid, molten or plastic state, and there must be created very good wettability of glued surface, very good wettability of wood before gluing or before application of painting or varnishes. Bonding strength depends on the perfect adhesion of glue to the surface of adherents, as well on good internal consistency, cohesion of adhesive molecules after curing. Regular or general adhesives used for woodworking industry have very good cohesion properties. Cohesion is the force which keeps molecules of the material together inside the hardened glue line, inside the glue polymer. There are maybe problems with adhesion of glue to the surface of such treated wood as thermo wood is. Here is some basic explanation of creation of good strength of good glue joint. And this theory is called mechanical interlocking theory of gluing. This theory says that mechanical interlocking is strongly dependent on the surface properties. As we can see on this animation picture, you can see that adhesive is penetrated inside cut fibers, pores or capillars, and adhesive creates large number of microdowel joints. So if we test such joints on shear strength, these dowels improves the strength of the joint. On these samples, there are real samples from microscopy, we can see penetration of phenol formaldehyde adhesive, which has dark color inside the fibers. This is plywood, so we can see this part is cross cutting, and the upper part is longitudinal cutting. So also we can see the adhesive inside the cut pores or inside the crossed cut pores. The same picture, another picture, very similar picture is here. Also here is the cut section, cross section, and here is the longitudinal section. And also we can see phenol formaldehyde adhesive inside the cut pores. This is the mechanical theory of gluing. We have more theories. One of them is adsorption molecule theory of gluing, which says that on the surface of each phase there are operating forces which are capable to bind different materials. We say about wood, about adhesive, and the third is surrounding. The phenomenon is called adsorption, and the adsorption is between the solid phase, between the wood, and liquid phase, between the adhesive. The contact area of two phases creates phase boundary, where is the free energy. And on free energy depends the shape of the drop. If the shape is like this, so the angle theta is lower than 90 degrees, we say about good absorption, and there is a very good assumption that the glue at the joint will be good and the strength of such glue will be very high. Another case, if the angle theta is more than 90 degrees, we say that adsorption is poor, and we cannot suppose good properties of such glue joint. Free energy on solid surfaces affects the flow of liquid adhesive, so the flow we can see here or here on the surface of wood, and this phenomenon is called wetting. Only good wetting of adhesive on the wood surface can cause good strength properties of prepared glue joints. The third theory, which is valid for bonding of wood, is the theory of chemical bonding. And there are created very strong chemical primary or covalent bonds between the adhesive and wood substrate. You know that the wood is composed of three main chemical parts: lignin, celluloses, and hemicelluloses. And these chemical fibers, these polymers, have three hydroxyl groups, OH groups. And for example, for polyurethane adhesives contain isocyanate groups, NCO, and here is very schematic chemical structure of polyurethane adhesive, and the group NCO reacts with OH group, and there is created very strong chemical bond. And this is the reason why the polyurethane adhesives are very strong, very resistant to heat, very resistant to temperature, very resistant to moisture, very resistant to water. Because these chemical bonds are stable, are very strong, and there is necessary very strong force to cut these bonds. This theory is valid also for formaldehyde adhesives, and for example, ura-formaldehyde, phenol-formaldehyde, or melamine formaldehyde adhesives create also chemical bonds with some function groups of polymers of wood. There are three theories which mainly affect the bonding of wood with adhesives. There are maybe 3 or 4 more theories of gluing, but these theories are not valid as significant, are not valid so significant for wood gluing as for gluing of other types of materials like glass, metal, or something like this. So if you want to glue or to paint some thermo wood, chemically created wood or heat created wood, you have to know how woodworking adhesives are creating, are hardening or cross-linking. For formaldehyde adhesives, uraformaldehyde, melamine formaldehyde, phenol formaldehyde or resorcinol formaldehyde, there are polycondensation adhesives, and the reaction is chemical process. The reaction is called polycondensation reaction, and from mentioned theories, there is theory of adsorption and theory of chemical bonding. These two theories mainly affect the strength of glue joints prepared with formaldehyde adhesives. Yesterday or the day before yesterday, we used polyvinyl acetate adhesives, and this type of adhesives hardens by physical process. There is the penetration of water from the spread adhesive into wood, or evaporation of water into surrounding air. There is necessary to keep open time. This time starts after spread and ends with the closing of both glued sides. The open time must be very short, maybe maximum 5 or 7 minutes. But here is only physical process, evaporation or penetration of water from the adhesive layer, and this process lasts maybe a few hours or a few days. So for this type of gluing is valid mechanical theory of gluing, interlocking system, and also adsorption theory, good wettability of glued surface. And for gluing of thermo wood, there are recommended polyurethane adhesives or EPI, emulsion polyisocyanates adhesives. Where is the chemical reaction and reaction of isocyanated groups with hydroxyl groups, or OH groups on wood. So these types of adhesives are very appropriate for gluing of thermo wood. In woodworking industry, we have more types of resins which we used. There are epoxy resins, there is a chemical cross-linking, chemical process, hot melt adhesives, there is the cooling process, which is physical process. Only cooling of melted adhesives increases the viscosity and creates strong adhesive bond. And there are caoutchouc adhesives, where the process is also physical, and there is the evaporation of the solvent from spread adhesives into the air. These types of adhesives have very long open time due to time for evaporation of the solvent and creation of very high viscosity polymer on wood surface. So the quality of the wood surface is very important for gluing, and we must speak about two qualities: mechanical quality or surface cleanness, and chemical quality or chemical properties of the surface. Before gluing, there is necessary to keep some elementary surface cleanness. Surface must be cleaned, must be machined, must be without any dust, any grease, any other matters which can cause poor wettability or creation of weak joints. The machining of the surface is necessary to do before gluing process within 24 hours, because there is a lot of aspects which can affect the prepared surface, and the main three are here. If you have some wood species with resin pockets, there is the danger of flowing of the resin on the surface, and if in this case the gluing is prohibited, or in this area is very problematic, because the resin has very high viscosity, and the pressure cannot spread this resin from this space. This is very often a problem when you are gluing, for example, arix or spruce, resin wood species. There is necessary to process the surface before gluing within 6 hours before gluing. Another problem which can occur before gluing or during the gluing is the surface oxidation of extractives and change of chemical properties of the surface. This is also, if the surface is open for a long time, the chemical changes can negatively affect the quality of gluing. And another reason for keeping the time is waking up the fibers due to air humidity. If the air humidity or high level of humidity affects the wood surface, the wood fibers are growing up. So there is also can be a problem at gluing, and the final shear strength of such prepared joint can be a little bit lowered. So we must take into consideration the roughness of the surface, undulation, and hairiness. Hairiness is cut fibers in the surface. The best type of machining of the surface before gluing is knife planing. We can cut fibers very sharp, very good. Sanding is the second place, because the sandpaper fibers can wake up after sanding. And the third is solving or peeling. There is a lot of fibers which are cut from the surface, and for example, the consumption of the glue is maybe 1.5 or twice times higher, or we spend twice more adhesive in comparison with the knife planned surface. This is the mechanical process, and the chemical quality of the wood surface affects mainly extractives, affects the wettability of wood surface, and this influence is very significant. Decreased wettability can also be attributed to the change in wood chemical composition. The major reason for the change of wood surface free energy is the migration of low molecular weight extractives to the wood surface and the oxidation of extractives thereafter. This is this point, as I thought before. So you can see the schematic picture, which can negatively influence the surface before gluing. There are extractives which are migrated on the surface. These extractives are migrated, or migration is accelerated with the pressure and the temperature. So if you prepare some thermal wood, on the surface of such wood is a lot of amount of extractive matters. And the wettability during the gluing of surface finishing by paints and varnishes are worsened. There are, for example, air bubbles or machining damage, some waviness or ondulation, or chemical change of the wood surface delignification, or particles, fibers. All these, or combination of all these factors can negatively affect the surface before gluing. On our exercises in my laboratory, we tested prepared larips, pine and spruce samples according to this standard. Standard is EN, European Standard 204-205, which is determined for classification of adhesives into 4 classes. These classes are B1, B2, B3, and B4, and these classes and this classification sorts thermoplastic wood adhesives according their water resistance against water and against the humidity. B1 is the lowest level. This glued material, bonded material is intended to use in dry conditions. And for example, D4, we say there are boiling resistant adhesives or boiling resistant joints, and these types of adhesives are intended to use in exterior conditions, but without direct impact of the weather, of the fog, of the rain on the glued joints. So we have prepared test pieces according to this scheme, according to standard, and we tested conditioning after 7 days in regular climate. Regular climate is 60% of humidity and 20 degrees of temperature, room temperature. And another set of pieces we tested after 4 days immersed in cold water, and we tested the shear strength. All results you have, and you will evaluate them maybe today. Another European standard says about the bonding quality, which is tested on test pieces. Test pieces are prepared from the glued board, like this, and this standard classifies 3 conditions. SWP is solid wood panels. Solid wood panel 1 is intended for use in dry conditions, and the test is 24 hours in cold water. Solid wood panel classified 2, they are intended for use in humid conditions, and the testing procedure is 6 hours boiling and 2 hours in cold water. And such materials intended for use in exterior conditions must be tested for 4 hours boiling, 16 hours drying at 60 degrees, another 4 hour boiling, and 2 hour cooling in water. And also these test pieces are tested on the shear strength. Shear strength is count like from dimensions of the sample, the width of the sample, and the height of the sample. For example, we have some tests from my laboratory, and we tested beech wood and spruce wood according to this standard, and we were looking for the relation of the type of surface processing. These results are for zone type of the surface. These results are for sanded type of the surface. These results are for plant type of surface, and these results are for smooth pressed surface, which is very related to thermowood as you used in your laboratory works. So here is the relation of the shear strength. Shear strength is here in megapascals, and from these diagrams we can see that the best results, the highest shear strength, had the planet surface, knife plant surface. If we have smooth or pressed surface, the openings, the fibers, capillars or pores were closed, and polyvinyl acetate adhesive cannot penetrate into wood and cannot create any microdural joints, or there is interlocking very poor. This type of gluing is for PVAC adhesive, and for PVAC adhesive, as I mentioned before, there is the main theory for gluing, mechanical or interlocking theory. Here are some scanning electron micrographs, and we can see the influence of the pressure. These pictures are taken from alder veneer, and here is the picture of regular wood, and here is the picture of the same sample after pressing at the pressure 4 megapascals at temperature 200 centigrades. And you can see the difference between openings of wood, between the shape and dimensions of fibers and pores and capillars of wood. This is the cross section, and another research we had for longitudinal tangential surface. Here is also alder veneer, and here is the picture of regular wood, and here is the picture of pressed veneer at temperature 200 centigrades and pressure 12 megapascals. You see very different type of the surface. From such prepared surfaces of veneer, we prepared plywood, which is also pressed wood, and we can see few relations which I would like to explain you. Here is the compression ratio in relation with pressure of prepressing of veneer, and we can see if the pressure is low, the compression ratio is low, and if the pressure is very high, the compression is also very high. So the surface of wood is compressed more, and the surface area is very smooth. Here is the surface roughness, and we can see the degrees of the surface roughness. Here is the regular sample, and we see that the compression ratio about 12%. We can see that the roughness is maybe only half of the previous state. This is the positive effect of quality at gluing of plywood, because this plywood was glued by phenolformaldehyde adhesive, and as I mentioned before, phenolformaldehyde adhesive is chemical setting resin, and there are created a lot of chemical bonds between the adhesive and between the wood substrate, between the veneer, and also there is very good absorption of adhesive on the wood, or wettability of the adhesive on the wood surface. If the surface is closed like this, the glue spread was lowered to amount of 90 grams per square meter. Generally is used the glue spread about 150 for such prepared surface. So when we can see that prepressed veneer has much higher strength properties than, for example, at 200 Celsius, and higher pressure than prepressed veneer at 100 Celsius. So here is another type of setting of adhesive. Here is more valid chemical theory of gluing, and we can see the improving of the strength of glue joints even in lowered amount of adhesive, maybe almost down to half. It's opposite than application of PVAC adhesive for bonding quality of such wood, where the smooth surface causes the lowering of the shear strength properties. Okay, that's all. Maybe I explained you the problems of gluing of thermally treated or pressed wood on the theory and on our own results which we obtained in past few 3 or 4 years. Thank you very much.
Professor?
Another question? Some questions?
Yeah. If somebody has a question, you can raise. Okay.
Have you also studied gluing of the particle boards?
Particle boards?
Yes.
No.
No, not here.
Not
okay. I was just thinking when Kronospan is so close to you, so that you are making some analysis or tests for them.
I cooperate with Kronospan. I am doing some tests, but I am doing formaldehyde tests.
Okay.
Formaldehyde, not strength properties. Not strength properties. Their laboratory is very well equipped for mechanical testing, and I do for them formaldehyde chamber method and perforator method very rarely, but also perforator method. And Kronospan had very good business with Japan. And Japanese wanted, according to Japan standard, desiccator test.
Yeah.
And I had this methodology, and I prepared testing of particle boards according to this Japanese standard desiccator test.
Okay. But you have studied plywood quite much.
Mainly plywood.
Also Finnish plywood.
I studied Ukrainian plywood, because I have very good cooperation with University in Lviv and a very big plant in Orziv near Kiev, and they are processing birch and alder, mainly these two species they are producing. Maybe Finnish plywood industry is based on birch.
Birch and spruce.
Birch and spruce, yes.
Okay. Any other question? You should ask now, because you should know what to write. This is written into your report. Okay. If you will come up with any questions, I think you can, where you can find Professor.
Just one question.
Yeah,
is that possible to share all these presentations with the group?
Yeah, it's possible.
Yeah.
Okay. Basically, it will be also on a video, so. Okay. Okay, so if no other questions, thank you for your report. Thank you for introducing us to the problematic with thermal wood and gluing.